Okay, so there is some that I've looked at, guys. You guys got to remember, because I'll be honest, the stuff that you struggle with is stuff that's worth a little remediation. Okay, be aware there are things that we're not going to have time to spend with. Right on. Okay, so we're going to start over here. Okay, how many of you guys remember what an exponential graph looks like? You remember? It's a curve. Will it ever cross zero if it's just in standard form? Why? A number raised to any power, when will it ever be zero? It won't, will it? Okay, I don't know if you guys can read this. This is y equals 4 to the x. So that's the first one we're going to start with. Okay. Now, when in doubt, if you don't know what it looks like, what do you do for a graph? Plot points, right? Without plugging it into your calculator. Okay, so here's my action. Because I know it's not going to cross zero, I'm going to have it a little bit higher here. Okay, that means it's going to work. Any questions so far? What's a good value to plug in? 1. Okay, 4 to the first. 4. So I plug in 1 and I got 4. What's another good value? 2. That's 16. That's all the way across. Okay. Not going 3. If it's already there for the second one, I'm not going 3. That's actually 64. I'm not doing 64 tickets. So what's another good one? 0. What's anything raised to the 0 power? Oh, think it one more time. 1, right? Anything raised to the 0 power is 1. That's something to understand. By the way, first off, y equals a b to the x. Okay, that is your general form. Where a is called your constant in this case, meaning, not your constant, back up. B is called your base, or your common ratio. Meaning, when we have this problem, for every x, guess what? For every 1x, what's going to happen to my y? It's going to be multiplied by 4. So 1 times 4, that's where it's got 4. 4 times 4, 16. 16 times 4. That's why they just keep going, right? Okay, so right here, this is my base. It's also called my common ratio. Okay? So if I did negative 1, okay, what is 4 to the negative 1? So you guys scribbled that on the test. Once again, what is negative exponent? 4. Whenever you see a negative exponent, just put him on the denominator. Okay, so that's 1/4. So at 1, I'm at 1/4. Okay, how about 4 to the negative 2? And it's just going to get closer and closer to 0, but will it ever touch 0? Now y again, just gets smaller and smaller. We're cutting each value by a fourth every time. If we're going right to left, we're going opposite. Instead of multiplying by 4, we are dividing by 4. Okay? Now, remember these graphs a little bit. Would you rather have your money grow quadratically or exponentially? You want your money to grow exponentially, and that's how it works. We are an exponential system. Okay? You guys know it takes the same amount of time to double 1 cent to 2 cents as it does $1 million to $2 million? It takes the same amount of time. In your bank. You put $1 million in and a penny. How long it takes for that penny to get to 2 cents as it does $1 million to get to 2 million would be the exact same time. Interest. That's what interest does. Now, most of our interests that are in banks right now aren't very good. Like, if you put it in a savings account, you're going to earn, I think, what, 0.5% per year? I put it in, like my 401k, I don't know exactly what it's used in, but, like, I have some. It's kind of like stock markets. It's more of a mutual fund. I don't know if you know what a mutual fund, where a lot of people put their money together and you put it together out there so you can buy more stock. So what happens is, on average, you want to at least make 8% on average for your money, because inflation is roughly 8% per year. So you want to make more than that, so your money's making more than inflation, right? Does that make sense what I'm saying? Because I remember back in the day when somebody said you could live off $1 million, right? Just through the interest. Nowadays, I don't think you could, because of what they were back then. You know what I mean? But anyway, it can work for you. We can show problems for you. So pretty cool. This is what started getting me to really think math was cool. Was exponentials and logarithms. Doing logs. Are you dying back there? Sure. Alright. Okay. So they kind of logarithms can talk. Did I ever talk to you guys about how CSI, how they talk about how long somebody's been dead? He's been dead 4 hours. How do they do that? It's called that, or Newton's law of cooling. So for dinosaurs, that's how they tell how long they've been dead, because of how much carbon is left in the bones. And it has a constant decay. Pretty cool. And that's when I started whoa, look at all this fun stuff. Okay. Alright, does that make sense? Everybody with me? Okay. So first, really quickly, what's the domain here? Negative infinity to infinity. And that should make sense because I can use any number I want, right? I can plug any number in for x that I want. Okay? What is my range? Do we ever touch 0? No. So 0 with a parenthesis. Okay, we approach 0, but we'll never touch it, correct? By the way, you really seriously just made my dinner. Okay, is everybody good there? Would that be considered exponential growth or decay? It is growth. How can we say, as we move left to right, what's happening to our values? Or increase. Does that make sense? Okay. Give me an example of exponential growth. There you know? Your money's one, right? It's growing exponentially. To a point. How about bacteria? They grow exponentially. Population probably could be, right? Okay, awesome. Now, we're going to do this guy right here, which is, if you can't read it, y equals a third to x. Okay, we ready? What's a good value to plug in? 1. What's 1/3 to the first? 1/3. Whoever said it, thank you. I think that was Steven over there. Was that Steven? Steven, I like. You're a good guy. Okay. 1/3 to the x. What about 2? 1/3 squared. 1/9. Think about it. It's 1/3 times 1/3. Straight across, right? 1/9. Because you multiply with the x. You guys look all so lovely today. This is going to be 1/27th, 1/81st. I ain't doing those because those are very small. Everybody good with me there? Any questions? Yes, sir, Bronson, sir. Yep. 1/9. Because what's going to happen here? As I go left to right, I'm going to be multiplied by a third. Okay, so let's plug in 0. 1/3 to the 0. Okay. What about -1? What's 1/3 to the -1? Yeah, because maybe say 3, right? Anyway, so I flip it. Remember, anytime you have a negative exponent, you can just flip the fraction. You guys remember that rule? So that's 3 to the first, which is 3. And then the second one would be 9. And then 27. So you guys tell me if I'm in standard form, with basically standard form, just to let you know, is just b to the x, where you have your common ratio raised to the x. What's something that we can see really quick? first off, let's already talk about its domain, and then we'll answer that question before we go. Domain. Negative infinity to infinity, I can still use any number I want, right? Range. 0. We always start at lowest, right? Some people look left to right, and whoever said it, was that you, Maddie? Yeah. It's okay. Some people look, well, it's coming down from negative infinity, right? Or from that side, but remember, that is technically positive infinity, so always go lowest to highest. Lowest to highest, right? So lowest to highest, that would be 0, parentheses, because we're approaching but not touching, right? Because once again, nothing raised to a power can ever be 0. Okay? Okay, so let's talk about similarities between these two real quick. Similarities, what can we see? Domain and range are the same, right? What else do you see? They both have the same... Yeah, they both do have the same asymptote. They have the same y-intercept, don't they? And why would that be? Notice first off, there is the basic form y equals d to the x, right? And any power, any base raised to the 0 power is always going to be what? This will always have a y-intercept of 1 when you're in your basic form. And that should make sense, shouldn't it? Does that make sense to you guys? Okay. Does it have any x-intercepts? Because we can't be 0, right? Once again, does that make sense to you guys? Okay, so this is our standard form, where in our case, what we've been doing here, our a value's been 1. Right? That makes sense to you so far? And then this is our common ratio, meaning what's being multiplied. Notice as I'm going left to right, notice I went from 27 to 9, 9 to 3, 3 to 1, 1 to a third to a ninth. What's happening as I go left to right? Dividing by 3 or timing by a third. That's its ratio. That's what it's growing by. This one's decreasing by a third. This one's growing by 4. Does that answer your question? Does that help you out? So what are we doing? What's the second one called? A growth or a decay? A decay. So, really quickly as well, I'll come back up there. But you will know it's a growth if your p-value is greater than 1. It is a decay. I should say the absolute value. Well, never mind. I'm not going to say that. Decay is when your p-value is less than 1. Now, to be honest though, p has to be greater than 0. Why would we not want my base to ever be negative? Anybody help me out with that? I'm just asking questions here for some thinking. Why would I want my b always to be greater than 0 and never, notice it's never equal to 1. Why would I not, first off, let's start there. Why should it not equal 1? 1 raised to any power is 1, so it'd just be a consistent line, right? Does everybody understand that? Makes sense, doesn't it? Okay, so that's why you don't have either of those. Okay, so your base has to be greater than 0, but it'll never be 1. Why would we never want it to 0? 0 raised to any power is always going to be what as well? 0, right? Does that make sense to everybody? Okay, so those kind of make sense, but why would I not want a negative? Because I can do negative 2 squared. I can do negative 2 to the third. What's wrong with that? Anybody know? Did you have a... Okay, that's okay though. It just looks like this. Like that, kind of. It's not continuous. It's okay. It's a function. It's just not a continuous function. Still haven't hit it yet. Go ahead. Let me explain. Notice what? This is showing I'm using even a half, a fourth, a third, right? What's 4 raised to the half? 2. Because isn't the half power a square root? Can negative 2 be raised to a square root? Or the half power? So there's a lot of places that are undefined. So therefore, there's so many places that are undefined that go with the places that are defined, then it doesn't. That's why we're looking. Because if that's the case, isn't there an infinite amount of roots in between any two numbers? Think about it. Between 1 and 0, isn't there an infinite amount of roots that you could not use for negative numbers? So therefore, it would just look like a hole, plus a lot of dots together. So it looks very confusing. Does that make sense what we're trying to get about that? Think about that, though. Can't have any negative number be raised to an even root, right? Or it's imaginary. Does that make sense why that doesn't work? Okay. All right. So last but not least, let's go ahead and do this 2, 3 to the x, 2, 3 to the x. Okay, and let's see what we can see on the difference here. So we start with the one we've been starting with, which is usually 1, right? So we plug in 1, what do we get? 6, because we got 3 to the first, which is 3. 3 times 2 is 6. Okay. Let's do a 0 this time, if that's okay, before we do 2. 0, what's 0? 2. Because anything raised to the 0 is 1. 1 times 2 is 2. So just to let you know, that a value is always going to be, if it's just there, it is a scalar. That's the darn word I was looking for earlier. Thank you. Okay. It's kind of, if you're just in a b to the x, that's always going to be your y-intercept as well. Now, we haven't talked about translating it, meaning moving it up or down or left to right. That obviously switches it, right? That's obviously going to affect your y-intercept as well. But if you're just in y equals ab to the x, then a will always be your y-intercept as well. Okay, because anything raised to the 0 power is 1. 1 times a is a. Does that make sense? Sir? We'll talk about that. All that does is instead of flipping him up here, he'll like go. Okay, and then notice if I did negative 1, that'd be 2/3. And then that'd be 2/9 and so forth. So it looks like this. Growth or decay. Growth, and how can we tell that prior to even graphing this? B is 3 and is greater than 1. You guys see that? Say the b value is 3, and notice what we did down here. If b is greater than 1, it is a growth. Are we feeling comfy so far? I'm not trying to push it so far, just making sure. You guys have done this supposedly in secondary 1 honors. You guys supposedly spent a lot on explaining the difference between linear and exponential. Linear is constant growth, right? Meaning you're multiplying by 2 or not multiplying by 2, but adding. Okay, and notice the domain's the same as well, right? And the range. Okay, because we haven't adjusted it yet. So once again, without adjustment, you'll never have an x-intercept, will you? With an exponential. And that should make sense once again, because what raised to any power will ever be 0? Nothing. And so if we're just in the basic standard form, nothing will ever be 0. Only way we can do that is by adjusting it, like meaning moving it down or up or those things. Mostly down. Is down, not just mostly. Okay, everybody good with me? Am I confusing? I'm not trying to be confusing. Is this a function? Just curious. That's some clarity I want to go over. Is this a function? Does it passes the vertical line test? Remember, vertical line test tells you whether this is a function. Some of you guys got messed up with doing horizontal line test to tell whether this was a function. Horizontal line test tells you if its inverse is a function. Does that make sense? Of the regular. Because if you already have a picture of its inverse, you just do the vertical line test to say, is that a function? Does that make sense? So like, for example, here's x squared, here's its inverse. Notice vertical line test for that, notice it shows you both right there. For this guy it works, for the function, for the inverse it doesn't. Does that make sense to you? Okay, we just barely talked about exponential growth and decay. Once again, A always is, well, this is also talking about, oh, sorry, Stephen.
I was just wondering, in exponentials, how do you do it?
Yes. till Thursday. Okay. And it's called a logarithm. A logarithm is a numbers. Okay. So if a, by the way, for exponential growth and decay, because notice if a is negative, what happens? Your graph looks like this compared to, that's your original, if a is greater than 0. If a is less than 0, your graph looks like that. You're not technically growing or decaying. Right? Does that make sense? So that's why they're talking about growth and decay as if your a value is always greater than 0. Okay? Everybody with me on that? All right. So this instruction says, identify each function or situation as an example of exponential growth or decay, and what is the y-intercept? You can't read this. This is what it says. Y equals 3, 4 to the x. Growth or decay? Can you give me a reason why? A is greater than, not A. B is greater than 1. And 4 is greater than 1, so that tells us it's a growth. Now, what would be your y-intercept? Because, once again, if you're in standard form, the a value helps you out with that, or we could just do the work. Remember, y-intercept is when x is 0, correct? So, 4 to the 0, 1 times 3, 3, hence why our y-intercept is 0, 3. Are we okay so far? Okay. All right, the other one, this one's slightly a little bit different. Y equals 11.75 to the x. Now they put it on the inside, doesn't matter. Did I put it on the outside? It does the same. Growth or decay? You need me to scroll up? I'm trying to help you, Bethany. No, you're good. It's not. I never complained once. Stretch you out. Huh? I'm telling you, I got covered. If you guys need blanket space, they're right there. I used to have really girls, mostly girls, that would come in and leave their blankets covered. That was back in the day when I used to be able to drop it down to 55. Those were the good days. I'm with you. Well, it helps that you got something around your neck. Yours is like holy. Not religious stuff. We don't know if it worships. All stuff. Okay. 0.75, is that greater or less than 1? So therefore it is a decay. What is my y-intercept? Oh my goodness, people. You're awesome. So far I'm kind of bored because this should be review for you guys. We haven't taught you anything fun. I like teaching you guys fun because then you guys are like, now, and then that's when I feel good. Okay? Because then I'm like, yes! And right now you guys are like, this is so boring. Okay. So if you put $2,000 in a college savings account for 4 years, the account pays 6%. If any of you guys find a savings account that pays 6%, you let me know. Okay? And your interest is annually, so it's annually. How could we do this? And I want you guys just to think about it. How can we do this? No! Rule of 72 tells you how long it doubles, doesn't it? I don't know how to do the rule of 72. Good way to place it. Okay, here we go. So, your first year. Okay, you put 2,000. Ooh, that's horrible. 2,000 bucks in. What's after 1 year? How much is in your account? Because you're going to make 120 bucks if you got 6%. Okay, so now you're at 2,120. That's after 1 year. So this is when t equals 0. This is when you put 0. You just say, hey, bank, here's my money. Use it. You guys know that's why they give you interest, is because they use your money. Just let me know. Okay. So this is after t equals 1. Now what do I do? Do I go back and say I just add another 120 to him? No, you got to add the extra money in there. So t equals 2, what would that be? No, you got to add it up. Well, now we got to add it to that. Okay, so hold on. Did you times this? How could I just do this without having to do this over and over and over and over? 2,000, right? I'm excited. I heard something going. Parenthesis. 1.06. Now, because why? Let's talk about the difference here. Why would we want 1.06? Well, what's happening here is that it's a growth. You're growing money. So doesn't this have to be greater than 1? So you take your interest rate and you take 1 and add your interest rate. You think about a 5% raise, Michael, maybe this helps you. You take a 5% raise or anything of those things, you take what you originally have, which is representing the 1, and you add your percentage. And notice that's the 1.06. So that's like if I multiply him through, 2,000 times 1 is your original amount, plus your rate times 2,000, and that tells you what it is. Does that make sense to you? So, and then you just do this how many years? So there's a basic equation. I don't know if it's up here. I think it might be on the next slide. Yep, it's on the next slide. Nope, it's not. I don't know. So let's do that equation so we don't have to do year after year after year. We can just plop it in. Whoa, Betsy. Betsy was my horse, girl. Ooh. Betsy was my horse. She ate apples. She ate too many apples. You can't eat too many apples. They found her. True? I don't know. That's what I was told when I was 5. Maybe it was a lie. They just want to send me to the doctor. I know, but it was apples. Not 20 bajillion apples a day. She found our apple trees. Ate a bajillion apples. She's a great horse. Well, she found her, which means what? Right, I'm horrible. What is this? 2,500. 95 what? 95 because they ain't going to give you that 0.3 cents anyway, right? 0.03 cents. They're cheap. You think about it, they gave that to everybody. That's a lot of money. So if they keep it, they give that. Anyway, that's how much money they'd have in their account after 4 years. Look, their money made them money. 6%, to be honest, in a savings account is pretty good. I don't know if you could ever just find a savings account for a while. Like a CD, you guys heard of CDs besides compact disc, but like money CDs? They're like 1.5%. That's really good. So if you can find a 6% bank account, let me know, like I said. I'll go bank with them. I don't know, I'm not sure, to be honest. That's what I'm onward! Okay. So let's see what all this stuff says. Oh, that's the thing that I just showed. So, you can model exponential growth or decay because of this formula. It says A of t, that says the amount in a certain time equals your original starting amount, that's what A is, 1 plus or minus r raised to the t. Now why is it a plus or minus? We could use it for growth or decay. So can somebody give me something that uses exponential decay? You what? Housewives?
Half-life.
Half-life? So decaying of like carbon dating. Price of a car, right? That depreciates exponentially. So it depreciates like at a 4% rate. You just go 1 minus 0.04. Does that make sense? You can find out how its value is. Everybody with me on that? Okay, your temperature cooling. All right, so let's look in here. Suppose you invest $500 in a savings account that pays 3.5%. It's behind my thing here. When will the account at least be $650? So I'm going to show you that one. That one comes with a calculator. I still don't have it on my calculator. So we want to know if we start with 500 bucks, and our interest rate was 3.5%, so is that an increase or decrease? Increase 1 plus 0.035 to the t equals, no problem. Oh, I didn't finish. Did I finish? Yeah, I did. The amount, after a certain amount of time, that's what that means, equals your amount you start with, 1 plus or minus, depending on its growth or decay, rate. Money, money, money. Money. Huh? We need to solve for t, but you can't do that yet until tomorrow. So, how am I going to show you to do this? That's when the handy-dandy calculator comes out. Hi.
Hi. What is that T? Is that a T right next to
That's
a
a 5.
That's a 5.
That is a 5. I know it's horrible. Yes, ma'am. So what we're going to do is everybody go y1. Go to your y equals. y1 equals 650. Whenever you have equal signs, just let this guy be y1 and let this guy be y2. All you got to do. So y2 equals 500 parenthesis 1.035 caret to the x or the t, it doesn't matter. Outside. Because it depends on the formula you're going to use. I would love to give you guys this project that the Salt Lake Community College does. It's a mortgage one. It's fun. Every time I tutor for them, help these guys do this packet, I think I just giggle the whole time. Like, this is awesome. Talking about mortgages and houses. You giggling over there? You're mocking my math nerdish? You are, Ashley. That hurts. My feelings. Sure. Okay, so first off, you're not going to see a great picture. Why? Your window's not appropriate. How long do you guys think it's going to take? Let's be honest for your x's or your t's. Well, you're not going to carry anything less than 0, so we can start at 0, couldn't we, for your x values, because there's no such thing as negative years. Okay? And then, how high is this going to be? What's the highest it's ever going to be to? 650, isn't it? Because that's where they intersect. So you want to go your y value, y max, to be at least a 700, I would say. You could go 0 to 700 for your y. Does that make sense where this is coming from? What do you guys think for your x's? Do you think hopefully you'll make 150 bucks in 20 years? Hopefully in 20 years, right? So let's go 0 to 20 for our window. So 0 to 20 for my x, 0 to 700 for my y. Check it out. Hopefully you can see the intersection. And then you got to remember, how do we find intersections? We go second, calculate. That's what the 650 is, a straight line. It should be covered. Give it a sec. lose it or it's expensive. Okay, what do we get, guys? How many years does it then take us? Sorry, that was recording the whole time. I apologize. What?
7.6?
So x equals 6 point.
7.6.
Alright. You guys know how we could convert that to months? You guys want to see? Just a curiosity, you guys know how? Nope. So here what you got? You got 6 point.
7.6.
Oh, 7 point. Sorry, I just heard that. 7.6.
6.
We'll just go like that. Okay. So what you do is, we already know it's going to take 7 years, and this represents kind of months, because this is 0.62 of a year, right? So you take this 6.26 of a year and times it by what? 12. And that tells you how many months. Not that I'm going to ask you to do this, I'm just showing you for coolness that. So now you're at 7.5 months, which is now, so now it's 2 years, 7 years, 7 months, and 15 days. 7.5. 6.26 times 12. Because you're taking this, which is in years, and how do we get years to months? We times it by 12, don't we? And then that tells us how many months, and we take this is representing 0.5 of a month, and how many, on average, we'll say 30. 30 times 0.5 is 15. Say again, Ms. Shumway? I can help you. I'm not saying you have to care about it, but like just take off the point, just take the 0.626. That's representing a year, right? So how do we convert years to months when we times it by 12? So just go 0.626 times 12. What do you get? Okay, so 7.5. So now that tells you took 7 years, 7 months. Now this is 0.5 of a month, so if you times that by 30, you get the 15 days. So you could kind of be almost exact right on, right? To tell you how long. You could do that. You could, but I'm not going to. I'm really okay with 7.626, to be honest. But I just didn't know if anybody cared. She has a degree, so don't even argue with her. No. I tell these kids, as soon as they get a 12-year degree, they can come back to full-time. Because this is talking about T, and T was in terms of years, right? So this is 7.626 of a year. So we already know it's for full 7 years. So isn't this not, there's got to be some months in there, because we're not exactly 8. So we take this part. See, my pants just jingle all the time. Okay, so we take this 0.626 and times it by 12. Oh, you can get a large sandwich today, guys. That's what mine do. Oh, let's read the deal. $5 combo at Dickey's. You can, no, I don't care. Includes a choice, I'm letting these people know. Includes a pulled pork or chicken sandwich, 1 large size, and a large drink at Dickey's. Or I got another thing. Oh, my Chase account. Oh, finally a check got cashed. I was excited for that. Anyway, onward.
So, what is it total? Is it like 7 years and 15 days?
7 years, 7 months, and 15 days.
Okay.
Does that make sense to you? No, 7.626 is the answer. I'm just showing you, if you wanted to be more precise, how to do that. Does that make sense what I'm saying, though? So I just take this 7.626 times 12. Okay. Are we doing okay so far? Okay. Awesome. I don't really care anymore. Onward. Okay. Here we go. Writing an exponential function. Ooh, this is a good one. Okay, so right here, we're going to write an exponential function. I want to know. It says, the table shows the world's population of Liberian lynxes in 2003 and 2004. Right there. That's a lynx. Looks like a cat. I don't know. Okay? If this trend continues and the population is decreasing exponentially, I don't know what the heck this is. Don't even look at this one. Don't look at this one. I don't know what the hell that's on there. Okay? So how many librarian links will be there in 2014? Let me show you how you're going to do this. Alright? So what you're going to do is this. First off, you need to find the common ratio. If it's exponential, what is the common ratio saying? You're asking yourself, how does this value get to this value? Does that make sense? So how does 150 get to 120? That's minus 30, but is exponentially minusing? What is exponentially doing? It's timesing by a certain number, correct? So how do we find that number? Well, that's what this is saying. You go ahead and take your y2, so 120. How does he get to from 150? Well, what we did is we multiplied what these guys both have in common. They have 30s in common, people. Get rid of those zeros. See how easy math is? Don't overthink stuff. Okay? What does 12 and 15 have in common? They have a 3. So that's a 30. So that's the same thing as you're multiplying by 4 fifths. Okay? So notice, if it's exponential, that means in 2005, it should still be multiplied. I take my previous answer, which is 120, and I multiply by 4 fifths. So 120 times 5, a little something like that, 24 times 4, which is 96. Is that what it is?
Yep.
So therefore, in 2005, you would say that's 96 links. Or, how could we start it? Let's show you another way. We could write an equation, couldn't we? Okay, how can we write an equation? Well, we're going to consider 2003 year 0. Does that make sense? So if that's year 0, that means that's your A value. Correct? So therefore, the population in terms of time, that's all, I'm just making it into a function, equals 150. What's our rate? 4 fifths, right? Raised to the t. So therefore, it happened 2 years after, right? So let's go ahead and plug in 2. Yep, t is in years, after 2003. So 2005 would be 2 years. And then we just plug it in, that would be 16/25. That'd be 6 times 16, which is, let's see how that works. How do we find the common ratio again? You divide your x value, not your x value, I don't know what to say. You take your y value divided by the previous y value. Does that make sense what I'm saying? I lost my football game. So do you guys see how I took my y value and I divided by the previous y value? Yeah. I would just go with this. Okay? Oh, now we're on 5 2. Kick that over to you because I've never hard time understanding. It's over on that side of it. Thank you. Alright, so now we're doing the properties of exponential functions. So basically, guys, what are we going to do today? On this part, we're going to talk about basically what does the graph do, which we've already known. Okay, so if I had my parent function, y equals 5 to the x. We did a quick chart, just to do a quick chart. I know you guys love me and my chart. Is that inside or outside my function? That's just part of my basic function. Okay, so first off, I have 0. I like to do my fab 5. When I plug that in, I get 1/25, 1/5, 1, 5, and 25. Am I multiplying by my common ratio of 5 every time? How does 1/25 get to a fifth? I multiplied by 5. How does a fifth get to 1? I multiplied by 5. How does 1 get to 5? I multiplied by 5. How does 5 get to 25? Does it follow my common ratio? Okay, so this is asking, I don't know if you guys can read that, that's negative 0.05. So now I'm at this graph. I still have some people confused on what is this inside or outside of my function. Because remember, things on the inside of my function, what does that affect? The x's. Anything on the outside affects my y's. And I looked at a couple charts on that last test, and that hurt some people. It's still apparent, still exponential, but now we're just going to flip it. So notice, oh, that's not a 0.5, sorry. I think it just got on there. Now it's part of my parentheses. So I fix that. Monkey ticky. I just noticed I was looking through some stuff, and you were on the summer list this week. Okay, so what is this? Oh, pi, sir. Pi, Bronson. This was just, it told you up here in the basic problem. So we're comparing this to its parent function. Sorry about that, sir. Are you okay with me? Okay. So, first off, I've never really talked about what it does. What is the math term for what the negative does? You guys know? It flips, so what is that? It's not called the reciprocal. Okay, so we're just not caring about the 0.5. We're looking just at the negative. What? It's a reflection. Okay? Because what happens, you have this axis, and it looks like the exact same graph reflected over the axis. It's called a reflection over the y-axis, x-axis, right? You have a negative on the inside, it's a reflection over the x-axis. Now, what does that 0.5 do? It's a scale factor. So is this a stretch, meaning it's going to go higher? Or is it going to be a shrink, meaning they're going to go lower? How do we know it's a shrink? Because it is less than 1. Does that make sense? So technically, if we were using words, we are reflecting over the x-axis with a vertical shrink of a half. With 0.5. Does that make sense to everybody? Yes, no, maybe so? That's the only difference. If we were using our words, just like we were saying back in our childhood, use your words, don't hit. I don't know, it just came to me. It's a good analogy. Yes, sir. A negative on the inside. Huh? Well, we're not going to do it on this one. Does that make sense? If it was like any other function, that's what reflection is. Okay, so the imperial, which was, once again, is this affecting my x's or my y's? Y's, it's on the outside, right? So therefore I still keep my -2, -1, 0, 1, and 2. And therefore I'm going to times all of those values by -1/2, correct? So instead of being at 1/25th, I'm going to be at -1/50th. Because I times by -1/2. What's a fifth times a -1/2? -1/10. What's 1 times -1/2? -1/2. What's 5 times -1/2? -5/2. What's 25 times -1/2? -25/2. So if we look at the graph now, here is it originally, just to let you know, kind of give you an idea. Here's our parent function, just to give you an idea. And here is what the graph looks like now. So notice, can you see how it shrunk it? Yes? Instead of being at 1, it's now at... Sir? Parent function. B to the x is technically the parent function.
So, do we ever do one that is like a x plus or minus something else instead of like shifts?
want to do it right now? What the heck? We'll do it now. Just because I like it. So, we'll go, here we go. That's going to be our parent. So really quick, once we're going to draw our parent function, or graph it really quick. So Fab 5 again, right? The bears stand there. So I like a fourth, a half, 1, 2, and 4. So everybody understand where they came from? Just plugging them in. So therefore, now let's go here. Is this something you're looking for, Stephen? You guys are mummies. Is it really that cold? My ears aren't really even toasty. Cold. You're struggling with this. You got a scarf. Are you okay? Yeah, you keep them. You guys are like refrigerator. If I put my cold cuts on you, tell you what, you guys keep the cold. Hey, so what's... That might sound weird, I'm sorry. Like turkey with ham. I like turkey. Okay, so what does this x minus 1 do? Is that inside or outside the function? Inside. See how it's up next to the x? It's inside. So therefore, opposite what we see a minus 1, so therefore we're going to add 1 to the x's. So that's negative 1, 1, 0, 1, 2, and 3. What does this negative 3 do to these values? This part right here. I'm going to just skip all those steps, really. It's okay, hopefully. So do you guys see how I maneuvered my x's from the x minus 1? Now I'm going to do my y's. You guys want to know how I'm going to do my y's? I'm going to do them both at the same time. So I'm going to take a fourth, multiply it by what? Negative 3, so that's negative 3/4. Then I add 2, that's 1 1/4, which is 5/4. Yes, no, maybe so. I take a half, multiply it by negative 3, that's negative 3/2. And I add 2 to it, I get a half. I take 1, I multiply it by negative 3, what do I get? Negative 3. Negative 3 plus 2 is? 2 times negative 3, negative 6, negative 6 plus 2. So 4 times negative 3 is negative 12. Negative 12 plus 2 is? There it should be. Was that hard? Okay, notice talking about, let's talk about it. What did this do? It took my graph and shifted it where? Right 1, reflected it over the y-x-axis, stretched it vertically by 3, okay? And then we raised it up 2 after that. Does that make sense what we did there? So now, here's what the graph looks like. Negative 1, here's 2, it's at 5/4. Right there. 0, you're at a half. 1, you're at negative 1. 2, you're at negative 4. 3, you're at negative 10. And what number do we approach now? We approach 2 because we shifted it up 2. Because once again, when will this guy ever be 0 in here? It'll never be 0, and 0 plus 2 is 2. That's the only way to get to 2 is if that guy was a 0, and will he ever be a 0? No. That was a margarine commercial back in the day. Remember that? No? How old are you? Oh, come on now. I know you're not supposed to ask a lady your age, but I do. You're just a year younger than me. It's okay. Where did you go to school? Lehigh High? Maybe you knew my... Huh? Okay, that's awesome. At least you're not a liar. Okay? let's just talk about this. This says 4 raised to the x plus 2. What does the x plus 2 do to our graph? So it shifts us. Whoa, I have a bajillion answers going on. Left 2, because it's inside my function, right? So that's your x's. Okay, I have 0.5. 5 times 0.25 raised to the x plus 5. First off, is this an exponential growth or decay? Decay, because it's 1/4, right? So what did that 5 do here? Stretches it vertically by 5, and what does the plus 5 do? Shifts it up 5. Awesome. Yep. Okay. This, I might have to have Miss Spangler come in. She was showing me yesterday. I can do the next one. Okay, we're going to do this one, and then we're going to have Miss Spangler come in and chit-chat. Because that one still made me think further. Okay, so we have a function. 110 times 1.16 raised to the d models value of an antique car. Antique cars go up in value after a certain time. Cars are good things, right? If you treat them good, they're nice and they're pretty, they can increase in value. So the value of a vehicle is 110 times 1.16 raised to the d. D stands for decades. 110 stands for 110,000. So that number's in thousands, okay? So it says, what exponential function models the value of an antique car after t years? So we don't care about the decades. We care about the years. So what do I need to do? So years is the same thing. So how can I put a decade into years? You take that decade and put it in to 10. Right? Divide it by 10. Because 10 years equals a decade, so y is going to be b over 10. Right? Is everybody there with me? You take your decades, divide it by 10. Okay? Yes, no? Now what if I just want to have a y, not a y up here, but t for time? Because I don't want to put d over 10 in here. I want to just have a y. So if it's 10y equals d, I can substitute that in just like this, right? So then now I'm at 110, parentheses 1.16 raised to the 10y, correct? Not 10y, 10t. We're going to call it t instead of time. T is time. Is that okay for everybody? And that is your value. Okay, but I don't want anything but a t here. I just want to plug in t. That's it. Can anybody tell me how I could do that without having that 10 in here? So can I just go 110, parentheses 1.16 raised to the 10th in here? Because, let me ask you this question. What does a power to a power do? You multiply, right? And isn't 10 times t 10t? Does that make sense? Yes, no? So therefore 110, parentheses, somebody help know, that's just raised to the 10th, 1.16 raised to the 10th. What is it? Nope, that's times 4.411 raised to the t. I wonder if I did that right. Let's check it. Somebody plug in 10 years for here and 10 in for our original equation. Because I might have did it back. 1 decade. Yeah, that may be different. It's different. All right. Somebody just plug that in. What'd you get? This is going to be way too high. Okay. So I was wrong. We did need to do this. So, let's start again. I apologize. V equals 110 parentheses 1.16 raised to the t divided by 10, because that's the same thing as a decade, right? The number of years divided by 10. Then we're going to bring in a tenth. That's what I need to do. I apologize. And that's still V want to call that. And now we're in years, but I can just call it T instead. Does that make sense what I'm trying to say? Because your decades divided by 10 is years. So then I'm going to put 1/10 in here, and I'm going to have a T like that. There we go. I had to think about that, and I apologize I didn't think about that prior to teaching you, but it is what it is. Can somebody help me 1.16 raised to the 10th so we can get a new equation? Do I got a second on that?
Yeah.
Okay. Now let's try that. Okay. Put 10 in for this value. Okay. And somebody put 10 back in, or 1 in for this value, because that's 1 decade, right? 10 years is 1 decade. You should get the same. See if we do. Which one did you plug it in? Second one. Okay. You got 126. How about you put a 1 in here for this one? It could be off a little bit because we rounded, obviously. Because we obviously didn't keep with the decimals down below. Awesome. We're close. Are we okay? Okay. Really quickly, let's see what the next part is. That's Bert. Give me 1 second. I'm going to put thank you for whoever said that. 3,000. E is just a number. R, what's our R? 5%, so 0.05. How many years? Times by 4. And it's just a plug and chug now. So, somebody help me out find that number. Nope. So you're going to go 3,000. This is what it'll look like. E, and then it'll go caret, and it'll go up in there. $3,664. That's where you're at. I will try to figure it out from Miss Spangler on what you do right there because I was confused. And so I will make sure by next time or whenever you come ask me questions, I will have that one because there is one of those on your homework. Okay.